All right. Hi, everybody. So this is going to be session 4 of, I think, 4, most likely, of GitHub 101 for open science projects. And this session is a bit more nebulous. So we talked originally about why we want to use something like GitHub for open science, why we might want to make things public. And then we talked about the maintaining a wiki as a kind of live thing that helps people work out where we are up to. So it's like a surrogate paper that changes with the project and keeps people informed in a way that's easy to understand and quick to read. And then we talked about issues as a way of having conversations about smaller things, which can be, the conversations can be had and a conclusion can be reached and the discussion can be closed. And whatever was discussed and learned during that can be folded into another part of the project, either on the wiki or somewhere else. So these things all have different functions. And I guess the last thing, which I wanted to cover as the main item, is just how we can make our project be seen. So how we can involve others. One of the most important things about putting things online is that you can share things in a machine readable and discoverable way, right? So we can search for things using search engines, for example, and on the assumption that AI is only going to get better, we can make sure that our project can be discovered and understood. So we sort of should try and post things with AI in mind, as the phrase goes. That's why we do things like smiles, strings, and other things, identifiers for proteins and stuff like that, so that we can be discovered easily. Okay, so that's all fine. But ultimately, also, in addition to that, in an ideal world, we would want other people to come along and get involved and help us and grow the team. This is the idea behind a lot of open source software, is that by making things available, you can increase the number of eyeballs on a problem and you can solve things more quickly that way. And there are lots and lots of examples of when that has worked. Certainly in science, we thrive on collaboration. So it's logical to say that if we can get the right people involved in our project, then we can solve things more quickly. And sometimes a crowd helps, like having lots of people making a molecule or something. And sometimes you just need a small number of people who know what they're doing to come along and help. Most open source software projects, for example, it's not hundreds of people. Most open source software projects that are constructive have just a handful of people who are motivated to contribute. And the key is, how do you find those people? How do you try and attract those people in, people who actually could make a difference? And those could include, well-placed senior people in pharma companies, for example, which is what we've seen in open source malaria and other places. Really valuable contributions. So the thing is, how do we get people to see what we're doing? The first comment, before we get to that, the first comment is, of course, that just to go back to a thing we said before, one of the reasons why it's really important to make the wiki and issues easy to understand is so that if people do find your project and do come along, they are quick to understand what it is you need and how they might be able to get involved. If people have to spend ages trying to figure out what you're talking about, everyone's busy and people will drift away. So it helps a lot if you remember who your reader is supposed to be and how to make it simple for them to understand the project. That's why the README thing on the front of your repository is so important. It's why your wiki has to be really simple. And why, if you're going to post an issue about something, that the question you're asking is easy to understand. Okay. So this is, of course, an exercise in making science clear, which is not bad anyway, because, of course, papers, the beginning bits of papers have to be clear. The abstract papers have to be clear, and a thesis has to be clear. But there's an extra reason here that you might benefit from people being involved if you can keep things simple. Your reader is a scientist of your level, right? So someone who could make a molecule and understand what the molecule is doing. You don't need to make it easy to understand necessarily for the general public, because it's unlikely that someone without a science education could help your project meaningfully. Okay, you can add things in there, of course, on the front page if you really want to, but ultimately you should be aiming to try and explain the project to someone who is like you, but unfamiliar with the project. Okay, so you don't have to explain what a molecule is and what a drug does, right? You can pitch it higher than that, but still, it's got to be clear. And really, the key thing is that everyone's busy, and so you've just got to try and make it quick to understand. When you do reach out and try to when you do write something for the consumption of people who might want to contribute, it does help if you can give the context of what you're talking about. So if you want to try to, let me just give you an example here. I'm going to share the screen here. I'm only on my little tiny laptop screen, so it might be more difficult for me to navigate this. But if we go to some page, no, actually, I'm not going to do that. It's the Phenoramos page. I might just use the thing that Shin posted overnight about his project. So he's just put up the some initial bits on the wiki for his project, which explains why we're trying to do something with this molecule and trying to understand where a cysteine might react. Okay, so he's just posted this. So I'm not going to criticize you, Shin, at all. You know, it's work in progress, right? But it's an early stage thing, and what you want is for people to quickly get what this project is about, right? So you want people to come along and understand this. You want people to understand the story so far, which is, yeah, we move some of this to one of the issues, right? And then there's a question that was being asked here, which is about how do we model the reaction of a cysteine on a protein with the molecule of interest, so that we can, get the adduct and characterize the adduct and figure out what's being formed. In other words, where is the cysteine being attached, right? So this is a question here, and imagine that you were forwarded this page, and you're interested, right? But you're trying to figure out, okay, what's the thing I'm being asked to do? How can I help here? So the thing has been introduced, obviously, with a scheme, which really helps, and you've got the thing about a question that's being asked here. But I think in this case, and I'm only saying this because it's a work in progress, because it's only just gone up. In this case, what you want to do at the top here is to say something like, very briefly, something like molecule X, which would be, the molecule there. So it can help if you can number it or something. Molecule X is known, I think, to react. I think the original data react with GSH, and you might think, well, actually, most people don't know what GSH is. You might want to say, you might want to spell out what that is and say, we also think that this molecule is reacting with a cysteine covalently on the relevant protein, which is the RDRP. What we want to do is figure out where on the molecule the cysteine is reacting, and isolate the adduct so we can prove that. Okay, and then try to link out, for more information, you can link out to the wiki. So there, what you've done is you've tried to explain what it is you want from people, and you are linking out to more resources, and that provides the context if you really want it. You've still got to try and keep it brief, right? So don't give a whole paragraph of stuff. There's a rule of thumb about emails that any email you send is supposed to be like 4 lines or less, I think, right? And the idea being that everyone's really busy and no one wants to read an email of more than 4 lines. And if you need to have more than 4 lines, you should add it as like an attachment or something below the email that you're sending. No one should ever be sending like a page of email, right? The same thing goes here, right? You want an introduction here that's no more than a few lines, and then a scheme or something, but get to the point quickly. And if you need to add more information, you link out to something. Okay. So in this case, you want to start out with something really brief and then link it to something else to provide more of the context if you need it, so people understand the question. Otherwise, this may be familiar to you, but to people outside the project, they will have no idea. Also, this is interesting because Shin's done a useful thing here of tagging people. So each of these people is a separate person on the project, and you'll recognize yourselves. And that's fine. The way that's presented can sometimes imply that you are only interested in people who are named there. So you could instead say, hi, anyone. We have a interest in this reaction for this reason. And then you can, if you want to, at the end of it, you can tag people if you want to, just to make sure they get the alert. So you could copy those things and put them at the bottom of the post down here if you wanted to. And that sort of implies you're actually interested in something from anybody, but you're just tagging those people to make sure they see it. Okay, so linking out to keeping it brief and linking out to context, providing context or linking out to more context is really important. What are people being asked and why? And how does this relate to the broader project? But it's got to be really super, super brief. Yeah. And in this case, the question is pretty simple too. So Shin's quickly expressed this idea about, whether or not we need to use N-acetylcysteine or the cysteine itself. So it's a defined question. And here, the title of this whole thing is using N-acetylcysteine as a substrate. You could, if you wanted to, say something like, is N-acetylcysteine a good substrate for you to use for, GSH mimicry, or, how do we mimic cysteine reactivity, protein cysteine reactivity in vitro, or something like that. You can also frame it as a question if you really want to get very specific. Yeah, and sure enough, almost immediately afterwards, Tim Wilson, our collaborator, answered, and there was a conversation that ensued. One thing that so once you posted this thing, you can tag people, right? But of course, only the people who are following this repository or you tag will be alerted to its existence. So the problem you then have is, okay, we would like some help from someone. What do we do? Well, there are a number of things you can do, I guess, and these should be pretty obvious. I mean, it's not rocket science here. One thing you can do is to try and just advertise what you're doing, right? To try and spread the word across your networks of people. To try and pick up people who are interested in chemistry and biology who might be interested in this. And so that's what I did here. I just quickly posted something because it's a defined question. It's simple to understand. So I just posted that as a tweet in this case, and I took the picture that Shin had already done, which is very simple. You just grab it off the GitHub repository. And then I framed it as a question. And then I named, Shin was interested in what was going on. And the link is there, so you can find out more, right? That's the link back to the repository, fine, which is crucial. And then I did a couple of tags. In this case, there's a Ready Avid actually has no Twitter or X account, I think by design. So I can't tag that account, but I could put in a little hashtag for Ready, which I think is one of the ones that they're using. And I tagged Tim because he was relevant to this. And then I, just reframe the question a little bit. Do we need to protect the nitrogen? And what I'm trying to do here is include, the relevant words here. You can hashtag these if you really want to. Include the relevant words to try and pick up anyone who may be interested. So I don't know about you, but I think that chemists really respond to pictures very well. So if you see that and you have any experience in the reactivity of these kinds of molecules, you'll immediately think, oh, wait a minute, I know what that is. I'm going to go and check out what the question is. And if there's any relevant, hashtags you can use that might pick up people, and that might help. I mean, that's very quick to do. And if we do this more, with consistent hashtags, we might start to build up more of a community of people we can call upon for helping out with some of the projects that we're doing. It's all about community building slowly. So that's a more kind of advertising thing, and it depends on your network, right? You can also do exactly the same thing on LinkedIn as well, which tends to be a more work-based set of people. My LinkedIn feed is really very relevant to what I do. So it's quite a handy thing. If you have bigger questions, perhaps, maybe like this, you pick up people who are interested, then you can also post things there because it's work relevant, right? It's not as if you're sharing some YouTube clip of some movie. It's a work relevant thing. So that's a kind of advertising thing. And there are also other ways of doing it too, right? I think Twitter and LinkedIn are perhaps the most work relevant things, or other networks we might think of that are a bit like those. Facebook is really much too kind of social to be of any interest, I think, but these two are pretty useful. All right, so that's the kind of advertising thing. And the other way of doing it, of course, is if you happen to know someone who is interested in this area. And And those people tend to come up from either people you know already or people who have published in the area. So one of the first comments that Tim made, for example, was, Shane, go and read, right? Which of course he's done, right? But go and read the literature, right? And find out relevant papers. And that might A, give you an answer. But B, of course, what it'll do is it'll throw at people who are working in this area, right? So imagine you did do your literature search in the last 3 years, someone had posted on a reaction a bit like this, where soluble solution phase cysteine was being used as a mimic of a cysteine that's on a protein and trying to figure out an adduct. Imagine you found a paper like that. And then, of course, it's relevant and you can just dump it right here, probably by editing the comment, right, rather than posting something as a new thing. And of course, you can just reach out to that person, right? So you can email them, because they may not be on GitHub, most likely not on GitHub. You can email them and say, by the way, I saw your paper X. We're having a similar discussion here. And you just put this link from here up there, and so people can see exactly what it is you're talking about. And because it's a public discussion, you tend to get quite a good hit rate of people responding to that and providing input. It may be a response by email. You may then have to, triage it or just select it and then maybe quote it, perhaps getting permission for doing that, and putting the comment down here. But it can also help you involve people that way. Now, email is a bit tricky because we don't usually use email because then people can't see what we're talking about. But you can use the email to post something on the issue here, and get permission if the quote that you're using is long, complicated, include something that you think might not be appropriate for the public domain. Okay, so reaching out like that is pretty good. This also goes for times when you are interested in a certain chemotype. So let me bring up another example, which is the ABHD2 project. And because this is a project which is currently ongoing. And okay, not much on the synthetic chemistry overview here, but hopefully, yeah. So this is a project where we're interested in the impact of molecules of this kind on a protein that has potential relevance for the development of new contraceptives. The molecules are very simple. And in fact, this one is pretty good. And the molecules that we made around it, as all of you all know, who saw Eve's talk the other week, are quite simple like this, right? So imagine you were on a project like this, and you were interested in this molecule as maybe the hit from some screen. Then besides, putting an issue up saying, does anybody have any molecules like this to hand? Is anybody working on molecules like this? Does anybody want to make any molecules like this? And these are kind of reasonable questions because the molecules are so small and simple. And besides advertising that need, you can also then, of course, take that molecule and do a similarity search in SciFinder and Reaxis and what have you, and find the 5 people who have published on molecules that most resemble this molecule in the last 5 years, okay? And by doing that, you can find the corresponding author, and then you can simply reach out to them and say, by the way, we need these molecules. Here's the public link to the page where we're talking about it. Do you have any interest in making some? Can we collaborate? And so these targeted reach outs are okay because you're not just blanketing the entire world with an email. You're reaching out to specific people who are working on very relevant molecules. So each time you have a new chemotype, particularly if it's a simple molecule, then you should try and do a quick search, of course, to find out who's publishing in the area. But it's not just that. You're not just receiving the papers that are relevant. You can also proactively reach out to those people and say, well, we're starting this thing. Would you like to be part of the project? Okay. That doesn't mean they have to join GitHub immediately or anything, but they can engage you in a conversation about availability of molecules or resources. And you can engage if people want to help you out by making stuff in a collaborative endeavor. Sometimes it happens that the PI that you email will punt the question to a student who might then get in touch with you, and that can sometimes lead to productive conversations too. Okay, so those who has made similar things, and then who might, I guess, want to make molecules. We have taken this a step further in some cases where the molecules are simple and have formed group synthesis projects. in the case of the mycetoma project on the aminothiazoles, then we found these molecules here to be of interest. So these guys here, these aminothiazoles, have a sniff of activity against the fungus involved in mycetoma. And so we've run synthesis projects where, you know, lab cohorts in universities and schools have made molecules of this kind because the chemistry was pretty straightforward. Right? So that's like a next level thing. If you know you want to generate a library, if the chemistry is relatively simple, if you think you're at a point where R group changing will help you fill out an SAR cloud, then and if the chemistry is relatively simple, you can think about doing a group project like this. They can take a while to organize. So if someone in charge of a lab class at a university wants to run something like this, then they would usually have to plan it months in advance, right? So it is again a longer conversation because you have to get approval for running it. You have to make sure people are happy running it in the lab. You might have to run the experiments yourself, get in the starting materials, plan the whole thing. We did this at UCL this year, and it happened at York as well. But in some cases, you know, master's level projects don't need so much planning and can be done quicker. But anyway, have a think about this too if the chemistry is relatively simple. And then I guess there were just a few other things. One is that, of course, if people do contribute, then even if it's a small thing, it's taken that person some time out of their day to do that. They've given you their attention. They've thought about the thing you're asking. They've posted something. It's really important to thank people, okay? And never take it for granted that people have given you some of their time. And that can be a number of different things, right? So you can just, you know, give people a thumbs up here, or you can reply and say, thanks, that's a good idea. I'm going to take that on, and then keep people posted. You can, if it's a really long thing, you know, if you want to email, but it's best to sort of try and keep things in the public domain, but always be thankful. And of course, you know, in some cases, people have come on board these projects and have become involved in the project to such an extent that they become authors on papers when they're eventually published. So you know, building a community of people who might want to help you out, never take it for granted. Always thank people. Always, of course, be polite, but always thank people for their time and their thoughtfulness. The other thing, I guess, is to, again, you know, because we're all busy, you want to, if you're a contributor to something, if you come along to something and you understand the question and you're interested, you want to be sure that you're contributing to something which is going to go places, you know, which is going to reach a conclusion and maybe get published. You want to be sure you're dealing with a team that is that knows what it's doing. So always try and remember to make everything correct. Okay, really perfect. So no, you know, spelling mistakes, no mistakes with the links, no errors in the diagrams. Everything's got to be just right, because one of the things that's guaranteed to make people wander away is a sense that they're dealing with, you know, for want of a better word, a bunch of jokers who are going to waste their time, right? You want to make sure that everything is absolutely perfect with no errors at all. And that conveys the idea that you've really thought about what you've posted. It's not just quickly dashed off, right? You've thought about it. You've edited it, you've made sure it's perfect before you post it. And then people are more likely, I think, to contribute to what you're doing. So I think little things like spelling mistakes and mistakes in chem drawers, for example, will probably put people off. So be careful with those. And then one last thing I think that we haven't talked about much, and it's a separate thing really, but on many of these projects, you will have spreadsheets of molecules as well. So for example, for a screen that we do, we often have a spreadsheet, an Excel sheet of molecules. And if your project starts to take off and you start making a bunch of molecules, then you will need a spreadsheet of all the molecules in the project. And this, I think maybe we've mentioned in person, but I'm not sure I mentioned it here. These are very easy to keep on Google Sheets. So here is the mycetoma sheet, for example, of all the molecules made and evaluated in mycotoxins, and it's hundreds now. And every project will have a slightly different requirement here. You will always have, a code and something about the molecule and what it is and who's made it and why, and links to pages and stuff like that. You'll always have that kind of thing, but the exact columns may change depending on your project. You may find it easy to have supplementary sheets which talk about specific things that come from specific sources, but ultimately you still want a sheet which has all of the molecules in a way that can be downloaded onto your computer and then uploaded to something like Data Warrior if you want to visualize everything. We tried to visualize molecules in the sheet and it becomes really cumbersome. So better just to have it here in a way that can be downloaded into an Excel file. And you can see all the molecules. So I mention this here because that can also, sometimes it's good to link to spreadsheets like this on your wiki and on your front page if they exist, because it can also convey to people that the project is quite mature and knows that data curation of molecules is really important. So as a way of conveying to people that, again, this is a serious science project, not just some hobby thing, having a link to the raw data like this can be really helpful. Similarly, linking to your lab notebooks is a really good way of showing that you're serious about the project. So in Open Source Malaria Series 3, for example, maybe we saw this before, on the wiki, there's the sources of data thing, and there's always lab notebooks, right? People who've done things and links to other things like feces. And again, if you come to this cold, you think, well, okay, this looks like a fairly serious science project. There's a bunch of stuff that's happened here. I can see the lab book, so I know that people are being serious about it, his lab book. And that gives me confidence that this is a real thing and not just something pretending to be a real science project. So it's not just about blogging, right? This is actually got real data here. So again, that's quite crucial. It's crucial anyway, of course, but it's crucial in terms of creating an impression of what you're trying to do. If you want a good example of I think how to write a wiki page that is, I think, useful, easy to understand, and helps to summarize a lot of complicated data, then the mechanism of action page on the Open Source Malaria Series 3 is a good one to go for. So this is a page that summarizes a lot of information that has changed over the years a lot, and has links out to lots of different things here. So it's a good one to browse if you're sort of short of ideas of how to do your wiki in a way that is easy for people to understand who've come to the project cold. And so, it lists various ideas about mechanism of action, but crucially links to where the detailed discussion has been taking place. So that if you want to find out more, you can just by going to those places, and we're not cluttering up the wiki page with lots of unnecessary detail. So it's a good one. I think this page pretty much helps. It's being rewritten right now because we've learned more about the mechanism of action, but it's still a really useful place that holds links to the key discussions that we had and the key data that was generated. Okay, so I think I've covered everything. So think about who your reader is. Keep everything incredibly simple because everyone's really busy. Try and provide context for what you're asking. I'm asking this, and the reason is this, not a whole paragraph, right? Just a brief description. You can link out to your wiki or link out to somewhere else to provide more detail. If people contribute, thank them, because it's great that they've done that. If you want to try and involve more people, you can advertise succinctly somewhere, ideally including a picture, or you can target people who you find have worked in related areas. Remember, this is an open science project, so there are no secrets here. If we're working on something that other people are working on, we want them to know that we're doing something, okay? Because then we can work together. And I think that is everything I wanted to talk about in terms of advertising. So does anybody have any queries about any of that? Or even better, suggestions for how we might do things better, or things that we're not doing that maybe we should be doing? Well, stop talking for 1 second. The rule that if you ask someone something on a Zoom call, you got to count to 10 so that people have enough time to respond. Counting to 10. All right. Look, if not, then
Matt,
yeah,
hi.
yeah.
Um, so are the collaborators sometimes the collaborators are new to this kind of things, of sharing the pages on GitHub,
Yeah.
sharing some results on GitHub. Majorly if they got involved with some of the work that is part of the project. Um, is it good to tell them before sharing any of the information in the GitHub that this is going to be shared, as an open source project?
Yeah,
Uh,
that's a very good point. So yes, it is crucial. The response to that varies. You know, some people find that clarifies things very easily, and that removes the barriers to contribution. Some people run for the hills, right? But it is important to clarify that, yes. And you can do that in a couple of different ways. One is to you can link to the paper I put out about the 6 laws if you want to, because that does cover everything. That was the reason for writing that. You can just say that everything will be shared freely online with a Creative Commons license. Um, the way that I find it is quickest in like an email, is to say that is to sort of summarize the first 3 of those laws that I mentioned, to say all data and ideas will be freely shared. Anybody can participate, and we will not take any patents. And those are the first 3, and that does clarify for a lot of people what the rules are and what they're getting themselves into. So anything that is put there on GitHub is freely available, and people are sharing it with the same Creative Commons license that we start the projects with. The only tricky bit is if things come in by email, and you then have to judge very carefully about whether or not that's being shared in the spirit of the project or not. And there's a risk that people may not quite understand what you're talking about. Often people think that when we're doing these open projects, we're just publishing them in open access journals. That's what's involved, and it's very much, well, that's obviously part of it, but it's very much more than that. So the to clarify that everything's going to be shared is a really good idea. And as people continue to be involved with us, that is clearer and clearer and clearer, right? But initially, if you have like a new contributor, it's a very good idea to clarify that's involved. Yeah, yeah, to avoid any unpleasantness later because people have given you something which is proprietary. Yeah, so it's a good point.
yeah, thank you.
All right. Anything else? I mean, one way to, I think in your mind maybe, is to clarify what's involved here is that once you've begun, and you've posted your background to the project, you've started putting data onto the GitHub repository like PowerPoints and Excels and things like that. And once you've started trying to talk about where the project's up to, and maybe posted an issue that talks about a specific question, like if you're designing some analogs, or if you're coming up with a new synthesis, or you're reporting on some new results that just came in from a collaborator or something. So the new molecule that came in for you, Kangping, for example, your recent result, Wellington, on the bromination, right? Things like that, which could form an issue to where you've got a significant new thing that you're trying to say something about. Then when you put that up there and you try and describe what that result is and why it matters, then it may come to your mind of, well, how, what would help look like? Do I need help with something here? Am I just basically updating people what's happening, which is fine? Or do I need something from someone? And so if you find you need something from someone, then you might start thinking about, well, what can I do to reach out to try and make sure I get useful input? I don't need 1 million people to see it. I just need like 5 really good people to see it, so that maybe they can get involved and we can work together. Okay. So maybe when you have a specific example of either a bit of news or a question or something like that, it might be more obvious to you what you should be doing. Yeah. Okay. Great. Sounds good. If there's nothing else, we don't have to fill the hour. I think I've covered everything on my scrawled notes. All right, great. All right, well, good luck. I think this is probably the last session we need, unless something comes up sometime, and we need to have some, session where we go through some examples or something, and we talk about, just a bunch of examples of good wikis and good issues, and where it works and where it doesn't, stuff like that. But we'll have a conversation about whether we need that and see how we go. All right. Good luck, and see you all in the lab.
Thank you. Thank you.
Thank you.
Thank you.